Okay, I'm going to solve a problem today. It's a word problem that came out of this book right here, An Introduction to Management Science. And it's out of chapter 3 out of this book, and it talks about linear programming. A good book. I had a YouTube viewer ask me how to do it, and I recognize the problem came out of this book. And so anyway, let's go ahead and I'm going to show you how to solve this. This problem is actually a pretty difficult problem. Especially if you're learning linear programming, how to set it up. So let's just go ahead and read the problem, and then I will proceed to set it up, and I'll show you how to do it. So this is a cabinet maker, and it's throwing. I'm not going to read the problem totally. I'll just kind of explain it to you. They have an order that came through, and they're going to outsource, right? So they have an order for some cabinets, and they're outsourcing to cabinet makers outside of their company. And this is, let's say they need 100 oak and 100 cherry. We don't know how many. It doesn't tell you how many they need, but they know in order to complete the order, cabinet maker 1 would take 50 hours to get all the oak cabinets done, or 60 hours to get all the cherry cabinets done. And like we say, we don't know. We'll just say theoretically we got 100 in this back order, right? So if we use this person, he's only got, or if we use this cabinet maker, or this shop, or whatever you want to call it, he only has 40 hours available. So he won't be able to complete the order. He can only complete 80% of the order if he does oak, and he can only, because 40 divided by 50 is 80%, right? And if he does, if he'll give part of the job to this cabinet maker 1, he can only do 2/3 of the order for the cherry cabinets. So because he's only got 40 hours available, or any mix of that, right? But you're not going to complete the job using this cabinet maker. And but he's cheaper too. He only charges $36 an hour. He's less efficient, right? Because it takes him longer to get the job done. Because remember, we're talking about the same number in the order, right? There's cabinet maker 2. He's a little bit quicker and he charges more. So I guess you get what you pay for, right? This guy's more efficient. He's only got 30 hours available. So he's not going to be able to complete the job either. You know, he could do some combination, but he only got 30 hours available. To complete the job totally, he would need 42 hours to do all the oaks, or 48 hours. He's only got 30 hours available, and so on. So let's go. So we need to solve what work do we give to what cabinet maker, how much, and how much of his time do you want to spend on each one of these jobs? And then we want to minimize the cost too. So this is quite a complex problem to try to do in your head. So let's just go ahead to save time. I'm just going to go ahead and copy this in here. And so I'm going to say, so I just copied this right here, right? So just to get that out of the way, so we don't need it anymore. So I'm just going to kind of get that out of the way. All right. So let me zoom in a little bit. Hope this thing is not doing what it's supposed to do when I'm zooming. Oh, I know what happened. If I want to zoom in, I got to click here, then I can zoom in. Okay, so this is basically just what we saw in there. And what we want to find, let's explain what we want to find. We want to find, let me just copy it to save time. We want to find the percent of hours available, the percent of the hours available each cabinet maker should work on each type of cabinet. Let me see if I can say that a little bit. Percent of hours available each cabinet should work on for each day. Yeah, so we want to know what percent. So he's got 50 hours available. Of those 50 hours, what percent should he work on oak? And what percent? Well, he's got 40 hours available, right? So what percent of this number of hours? How can I explain this? Maybe this is the type of problem, if I proceed, it'll make more sense. Now let me just proceed here. So the first thing we want to do is we want to declare our variables. Again, I'm saving time. So instead of typing all this, I'm going to just put it in here. I'm going to set it up. So let me see if I can. Okay, so the percent. So we're gonna. These are my variables. I'm gonna call them C1s. Cabinet maker 1 oak. Cabinet maker 1 cherry. Cabinet maker 2 oak. Cabinet maker 2 cherry. Cabinet maker 3 oak. Cabinet maker 3 cherry. Well, I'm going to be solving this a little bit different than the book because I don't want to. The things might be out of order a little bit compared to the way. I'm not going to solve this exactly like the book because I'm not going to. I want you to work on this, right? Even though I'm not your teacher, I still don't want to give you the answer too easy, but you should be able to figure it out from what I'm showing you here. So, so you always declare a variable because that's what you're solving for. So what I'm saying, if my answer for C10 is 50%, that means I would work 25 hours on the oak, and I'd complete. So I complete 50% of the job. That makes sense? I complete 50% of the job if I work, and I'd work 25 hours. So 0.25 times 50 would be the number of hours I'd work. That makes sense? So this is the percent. Maybe I worded it a little bit wrong, but the percent of the job I would complete. Let me say the percent of job completed. Let's put it that way. Job completed by cabinet maker. I think that makes a little more sense. Percent of the job completed by cabinet maker 1. And we know it takes 50 hours, so so if you do 50% of the job, then it would take 25. You use 25 hours here, right? That makes sense? Remember, you only have 40 hours available. We're going to put all this in here. So basically, that's what. So we're solving for the percent of the job they're going to complete on each one of these. That makes more sense. All right. So once we declare our variables, we can take these variables, and I'm going to copy them. And I'm going to paste them across here, transposed, so I can start setting up my equations. So, and we know that these all have to be, we can't work, all of those, we have to work, we're not going to hire them for a negative percent. So we want them all to be greater than or equal to 0. And the first thing we want to do is our objective function. And our objective function, remember this is the percent. Whoops, I keep doing that. Let's not do that. So remember this is the percent. So my cost is, so we want to minimize cost. So this is going to be equal to $36. We put it, this equals $36 times the number of hours, and that's going to be taken times this percent of the job that I complete, right? So if I do 50% of the job of the order, well, I'm going to do 25 hours, right? So it'd be 25 hours times 36. So that would be my cost if I did 100%. My cost would be $1,800, right? Of course, I couldn't do 100% because later on we're going to find we can only do 40 hours. We can only do 80%. Anyway, so I'm going to keep going. So this cost, if I did 100% of the time available, it would be this times this, right? And this cost for cabinet 2 for oak would be what the oak guy charges per hour times the oak, or what cabinet 2 charges per hour times the oak. And this would be equal to that times the cherry, and this would be equal to that times the oak, and this would be equal to that times cherry. So let's let me double check these. I'm going to zoom out a little bit so I can just make sure oops. Okay, I had to pause the video. I did something I hadn't done before. I clicked this button by mistake when I was trying to go plus or minus. So to get back to that, I have to click this. Okay, so I was going to zoom out a little bit. I just want to double check. So this is that times that. I'm going to hit escape. That's that times that, hit escape. It's always good to double check your work, especially if you're talking. So that all makes sense. And we want to minimize this. Because it's cost, right? Okay, so now we're going to do some of our capacity. So we'll say the cabinet maker 1 capacity. Okay, so cabinet maker 1, their capacity, well, it's going to be equal to, well, we know that it's 50 hours here, and we know that they have 60 hours here. We know that the percent of time we can work, so these are all going to be 0 because we're not talking about the other cabinet makers. And we know the percent we can work, and we only can work 40 hours, right? So even though, so 50 times whatever percent of the job we complete here plus 60 times whatever percent of the job we complete here, has to be less than 40, okay? Because we only have 40 hours available. And then we can go to the cabinet maker 2 capacity. And now these are going to be 0. And we know that this is going to be equal to 42. And this is going to be equal to 48. And these are going to be 0. And they have to be equal to 30. So we only have 30 hours available. And again, that's going to be less than or equal to. At most, you can use 30 hours. Okay, and then we can do cabinet maker 3 capacity. And these are all going to be 0 because we're only talking about cabinet maker 3 now. And this is going to be equal to 30. And this is going to be equal to 35. Remember, these are all going to be times the percent of the job they're going to complete, right? And all those hours together, they have to be less than or equal to. Now, see how I'm not typing these numbers in, am I? I'm actually referencing. I'm referencing what I'm given up here. And the reason I'm doing that, because automatically this information down here will change. If I change these numbers, this information down here will update automatically, right? And that can be very handy if later on we want to change variables. So now we have the capacity. So now we have to make sure we fulfill. So I'm going to say fulfillment. How do you spell fulfillment? Fulfillment. I guess that's also 2 L's too, right? I don't know. Might be 1 L in the second one. For the fulfillment for the oak, well, we know that oak is going to be, we want to have 100% fulfilled for the oak. So the oak is anything up here with a O in it, right? So cabinet maker 1, 2, or 3 all could be working oak. So it'd be 1, 0, 1, 0, 1, 0, and that has to equal 1. Oops. So this, I can't type an equal sign here, so I'm going to do an apostrophe equals. That way. So the percentage of the job that I complete in all 3 of these have to add up to 1. So 1 times the percent of the number of oak. Remember, we're just talking about oak cabinets, right? So if I did 25% of the job here, I'd have to do the other 75% of the job between these two. They'll have to add up to 1. So it's kind of like a weighted average, right? If they're right next to each other, I could do a sum product. I could do these. I could go sum product these, sum product these. But in this case, we're just, we don't know the answer here. So we just know 1 times the percent here, plus 1 times the percent here, plus 1 times the percent here. That has to equal 1 because we have to fulfill it. This is a fulfillment for oak. And we can also do the fulfillment for cherry. Once you get the first one figured out, the second one's pretty easy, isn't it? So we know this is going to be 0, 1, 0, 1. 1, and that has to be a apostrophe equal 1. So those are basically, now that we've written these equations, now all we have to do is just have Excel figure it out for us. Because figuring it out is the hard part, right? If you try to figure this out on your own, it would be very difficult. But we can make Excel do it for us. So to make Excel do it, once you set up the equations like this, it's very easy. All you're going to do is I'm just going to go down below here. I'm going to go equals this. I'm going to set it up down here. I'm just going to copy all these down below. Oops, I just want to copy what's there, right? And then let me guess these. So I'm going to go this equals this. Well, let me just copy them. I'm going to copy these. And let's say we're going to spend 10%. We're going to complete. We want to add up to 1, right? So let's just we don't really care what it adds up. We'll say we'll spend. We're gonna allocate 10% of each one of these. I'm going to allocate 10% of 50 hours here. 10%. I'm going to do 5 hours here, 6 hours here, 4.2 hours here, 4.8 hours here, 3 hours here, and 3.5 hours here. So I'm just guessing. We're going to have Excel figure it out later, but right now we're going to guess. And we have to make sure we have the constraints in here, so I'm just going to repeat them. And I'm going to copy that over. So I just have these, I'm just pointing to that. I try to point to everything above, that way if something changes here, it changes down here, right, automatically. So this is pointing to this, and this is pointing to, if you look at this, hopefully I have it pointing somewhere. This should be pointing, ooh. So I typed 40, so that was a mistake, right? I shouldn't type 40. I should go equals this, right? And this should, so I did that one right. That one's, okay, so you always want to have, okay. All right, so now we have it all set up. Now here's the tricky part if you've never seen me do one of these. I'm going to highlight where I want my answer. And we go equals M multiply. And I want to multiply all of these times the transpose of, I always spell transpose wrong, at least I know I do, so I correct it, times these, times what I'm guessing, close the parentheses twice, then you have to hold down Control C, TRL, hold down Shift, SHIFT, and then hit Enter. Now, so if I change these things, if I change this to 20%, it'll change everything down here, right? So anytime I change something, it's automatically going to update it. So I'm going to have Excel guess these in order to minimize this, right? This is the cost, right? So we want to minimize this. I'm going to go ahead and format that as dollars, right? And we want to minimize that by changing the percent of the jobs I complete over here, right? And then I have these capacity constraints and fulfillment constraints. So I'm not fulfilling in my, because I don't have these equal to 1. I have to do all the old cabinets and I have to do all the cherry cabinets. All right, so here's what we're going to do. Is we're going to go to Data, and we're going to go to Solver. If you don't have Solver, you go to File, Options, Add-ins. Under Excel Add-ins, you go to Go. You would check Solver here. I'm going to uncheck that because I don't like that there. And then I'm going to go, but I have Solver checked, so I'm going to leave it that way. I'm going to go OK. And then when you go into the Data tab up here, go into Data, you should see Solver here. So I'm going to go to Solver. And when it first comes up, it's going to be blank. And first it says Set Objective. My objective, we know this is the objective function, so my objective is right here. And I want to minimize that because it's a cost, right? If it was profit, I would want to maximize it, right? And it says, well, what cells do you want to guess in order to max? So it's saying, I want to minimize this, and it's saying, what cells do you want to guess? Well, I want to guess these cells right here. Right? I want to change those cells until that becomes a minimum. And then I have to add these constraints, right? So I'm going to go Add. I'm going to say all of these, they all have the same sign, right? So I'm going to do them all at once, are less than or equal to all of these. And then I'm going to add another constraint. I'm going to say these two, well, that's got an equal sign, so I'm going to change this to equals these two. And then, so I've added those three and I've added those two. I'm going to go OK. So I've got all those constraints added in. And the next thing I'm going to do, I'm going to click this, and then what that does, that makes sure, do you remember up here where I said they're all greater than 0? I make sure we don't have negative percents. Okay, and we can leave this on simplex because it's just regular linear programming. And now when I go solve, these should change down here. So I'm going to go solve, and before I go OK, I want to see the sensitivity report. It's always good to have it output the sensitivity report, and I'll show you why in a second. And then I'll go OK. Now, you want to be careful because these percents aren't exact, right? I could take them out a couple percents. Now, depending on your book, they might want a decimal. Maybe we should leave it a decimal, right? So it says to use 0.271% of my time, or 27.1% of my time should be, I should use 25%, 27 per, I want to complete the job, 27.1% of the job should be done for the oak, should be done by cabinet maker 1. Well, 27% of the job, he's going to need 27.1% of 50 hours. So the number of hours, I could go down here, I could say the number of hours I want each one of these to work. So on this one, on the oak, I want him to work this times 50, right? So I want him to work 13.54% of the job of his time available. I want him to work on the oak, and that's going to be 27.1% of the job is going to complete. So here I'm going to go equals this times. So this is cabinet maker 2 cherry, and his time available for cherry is right here. So I want them to work 30 hours. Which happens to be the maximum amount of time, so he can't work on this other job, can he? He can't work here because he's using all his 30 hours. Here, he had 40 hours available, and he only worked 13.54. So let's just continue this just so it kind of makes sense. So this equals 72% of the job is going to be done cabinet maker 3 for oak. Now we can see what's 27.1 plus 72.9. Now we know I got 100% of the job done. So we could guess, if we know this, we could guess this, right? Because this is the only guy left. You know, this is 62.5%. Well, this guy, cabinet maker 3, is going to do 37.5% of the rest of the job. So that's going to be equal to this times how many hours available he had there. So that would be the hours they work, right? So the dollars, I'm just kind of summarizing this. You don't have to do this. I'm just summarizing it for you. So this equals, I mean, we answered the question already right up here. You know, these are the answer. But I'm just showing you how it's working. So this is equal, so how much money am I going to spend? It's going to be this. We're going to spend on labor, it's going to be this times, well, that guy was $36 an hour. So let me make this with a, and this is going to be equal to 30 hours times $42 an hour. And this is going to be equal to 21.88 hours times $55 an hour. And this is going to be equal to 13.13 times $55 an hour. So if I copy this format across, let's just add those together, and you'll see, let's use AutoSum. So that adds up to that cost, right? So this is the hours each one of those shops would work on each one of these products. And we know that that plus that equals 100%, that plus that equals, so everything seems like it checks, right? So this is the answer though. So he's going to do 27% of the job. He's going to do 62% of the job for cherry. The question is, it's kind of weird, right? Because why? These guys are more expensive, right? These guys are more expensive per hour. And I'm having them do most of the work, aren't I? I'm having them do, He's using all his hours, right? That's 35 hours. And so I have the most expensive guy using all his hours. Well, the reason is this guy's not as efficient, right? Because he's $36 an hour, but this guy takes 30 hours to complete the job. This guy will take 50 hours to complete the job, right? So if I take equals this divided by this times 55, it's actually costing him $33 per unit. So it's actually cheaper than that, right? So, but the nice thing is Excel figured it out for us. We don't have to think about that too much. So anyway, so our answer, like I said, our answer is right here. You could call this percent if you want. You have to put it in the way the book wants it, right? If the book wants a decimal, you want to make a decimal. How many ever places it wants. But that's my answer. Now, there's some other things we could look at. Like you could see here, we used all our capacity here, so there's no slack here. Right, but there's slack here because we could have used more capacity on this one. We only used 13.54. So this guy, even though he was cheaper, he was way less efficient, so he didn't use all his time. He just used what we needed, right? And he was cheaper per hour, but he wasn't cheaper per job, right? Because it took him more time. Anyway, let me see what else. Well, let's look at the sensitivity report. So a lot of times this could be called the shadow price. Sometimes you call it the dual price, right? So we know right here there's no slack, right? There's slack here, right? This has slack. You call it slack, right? One way you could define slack is I could do this. If this is less than or equal to, I could have slack. Well, that's going to be equal to this minus this. So in other words, it doesn't matter how much time I have available for this job because I'm only going to use, I could have 41 hours available, but I'm still not going to use more because I only need that many hours. The optimal solution doesn't use all this cabinet maker's hours, right? So I have slack. So in other words, if I give this guy, if I say, well, why don't you work some overtime, work 42? Well, it's still not going to make a difference because I don't use all those hours. Okay. So that's what it's talking about here. This is the shadow price. Well, it's not going to, if you increase the hours, it's not going to really. Remember, shadows, sometimes you call shadow dual price depending on the book. Okay. Now this one, it does. Like this one here, this one's showing that we don't have any slack, right? So if we increase this to 31, well then if we increase that to 31, let's just show what happens here. So I'm gonna copy this. I'm gonna paste it in here, Control V. I'm gonna paste it as a value so we have it. So this is the cost. So now I increase this to 31. So let's see what's happened. So I'm gonna go to Data, Solver, Solve. Okay. Now you will see that the cost went down. How much did the cost go down? It's going to be equal to this minus this. So it went down $1.75. So if you go here, that's what it says here. If you increase this, if you give them one more hour, well, you're going to lower the total cost by $1.75 all the way up to 11.14 hours. So I can only give them like anything after that, then it's not going to work, right? So 11.14 hours per hour, I'll reduce the cost that much. Okay, so in other words, the most I could reduce the cost would be equal to 11.14 times 1.75. So if I increase this by up to 41, if I increased it to equals this plus this. If I increase it to 41.14, then that would decrease my cost. So if I went here, let me go equals this. If I solve it again, let me take that out a couple places. I go Data, Solver, Solve. Okay. Now you can see, now I've reduced, so I increased this from 30 to 31.14, which just says the most I can increase that. If I do that, well, then I'm going to lower my cost by 19.5, and that's what I did, right? I lowered my cost by 19.5. Hopefully that makes sense. I know I'm going kind of fast. So I'm going to move this back to what it was. It was 30. I'm going to go to Solver, Solve. And that brings it back to the original solution, right? That's what we had originally. You can see these are the same again. And this has changed. All right, so what else can I tell you? I think you should be able to reason it out. If the book asks any other questions, you can actually do what it says, right? So if it says, well, what if this change? What if this price changes? How does it affect? We can run Solver again and see what it affects. So what you got to do is you got to take things, you got to kind of copy and it's going to change things. So you got to like I did here. I copied it over here and pasted it as a value, right? That way, when it changed it, I could see what happened. Or you could hit Solver and just watch what happens by changing whatever here up here. Does that make sense? The sensitivity report, you can get a lot of information from that too. I'm not going to spend a lot more time because it's already been 30 minutes. You can get a lot of time. Now, like I said, I may have solved this a little bit different in the book. Like these columns might not be in the same order, but it should be pretty close, right? So anyway, hopefully that helped. I'm going to have my picture come up here. If you want to subscribe, if you click on that picture, I think it'll take you to somewhere to subscribe. If you like my video, hit like. And if you want to give me a comment, that would be great too. I haven't done very many word problems, so hopefully this is helpful to kind of see how to work out a word problem. This is a very difficult problem, by the way. So if you're understanding what I'm doing, you're doing very well, because this is a very, very difficult problem. So anyway, hopefully that helped. That's it for today. Bye-bye.